sort of import the other Excels, I don't know why, the newer one. So save it as Excel 97, so you can then import it using the import XY. And by importing XY, it will associate to that data entry, the X and Y in your map. So when you go to your lab8 interpolation directory, there is a data, and that's your data set you have to upload, okay? Because it will need a particular reference frame to being able to import the X and Y. Make sure you put it all on your desktop or somewhere in one location, so if the map package doesn't work for some reason, you can zip it up. And it's not a lot of information, it's only the suburbs and the local area council, but it's enough because all we need is that coordinate system. So we can import our XYs into that. And then you will create the point layer for your weather stations. Okay, and that's BOM page. Okay, and as you can see here, you've got the rainfall, daily observations, and then enter location. Bronte. Okay, we want Bronte, New South Wales. Oh, here we go, yeah. And excuse me, and then just select all the ones that are within 15 kilometers of Bronte. Okay, so 12.1 Marrickville Golf Club will still be included. Okay, it's a bit of a work because now you have to put basically every single station into your Excel sheet. Okay, when you click on the station,
go to this. There's just a link. Okay. Yeah.
okay, get data. So that will be my it's kind of useful. It's really annoying. Ah, here we go. Okay, so we've got the Rose Bay Station. Okay, what do we need for that? We need latitude. Okay, so if you go back, I'll just make that smaller. Okay. So if you go to this one, okay, so in latitude it says 33.3, I think. So it says 33.88 degrees south. So what we need to write down is 33.88 with a minus, yeah, so it's minus 33.88 for latitude. Okay? You have no idea what we're doing? So we need to put that into an Excel. Okay, it should be here somewhere. Excel. Make sure you save it as 97. Because for some reason the system doesn't take anything that's more than that. I don't know why. But. Okay, so save as. Put it in the same directory, it just makes it easier. Okay, and then save it as Excel 97. The XLS, okay? ArcGIS can't properly read XLSX, so we have to use the XLS. Maybe they're going to fix it at some point in future versions, they haven't done it yet. Okay, and I'm just going to call mine weather stations. We can call it whatever you like, doesn't matter. Weather stations. Okay, and then put a heading, so it's latitude. Oops. So latitude. Longitude, and what else do we need? The highest daily rainfall, yeah? Highest daily rainfall, and I'm going to use for January, okay? I'm using January, but you can use any month you want. Just ensure you always use the same month for all the stations. Otherwise it won't be very useful. Actually, we want to also put the station name, obviously. Okay, so we just add another one here. Okay, so we also want the station name, obviously, yeah? Okay, so when I look at my data here for my one station that I'm looking at, it's Rose Bay. Okay, so that's my station name. Okay, latitude. Latitude is 33.88 degrees south, and we know that it can't read south. We only can have numbers. And here we can see that latitude south is minus. So in my table for latitude, I'll put minus 33.88. No degrees, nothing, that it will know that's what it is, and the minus tells us it's south. And the longitude, longitude, sorry, not you. Oh, sounds wrong. Okay, longitude. Yeah, is 151.27 east. When you look into the description, east is plus. So So you can put a plus or you just don't put anything, just like the normal math. So it's 151.27. Okay, and then I want the highest daily rainfall. So here we have the highest daily rainfall at the bottom of the table. Down here, highest daily rainfall, and it's here for the different months. Okay, so this is January, February. For some reason, it doesn't actually have. hang on. Yeah, it's a magnifier. Okay, here we have. And then we should have highest daily rainfall somewhere underneath. Hang on, I have to make this smaller. Yeah, otherwise I can't look at things properly. Okay, so there should be highest daily rainfall, not just for 1 year. Hang on. You can actually look for all years somewhere. Ah, here we go. Down here, at the bottom. That's a summary for all statistics. Just wondering. I thought it was it. Yeah. You see, there's a summary for all years, and that's the one we're using. Otherwise, it's just too much of a worry. Okay, so we look at highest daily rainfall. Choose 1 month, and this month you're going to use with every station. It has to be the same month, right? Otherwise, it doesn't make sense statistically. Okay, so I'm just going to use January, and that's for mine. That's 194. Okay. Save it. Okay.
It's not 100. Oh, we're using the one at the bottom.
Okay, and then you do this for all the other stations within 15 within 15 kilometers. And you can see it's basically all the ones that are displayed, yeah, including Marigold Golf Club. I'm just going to get my pre-made Excel so I don't have to do it again.
Wow.
So how many stations did you find?
Eight.
12? Okay. You only have 8.
No, I was so many, but I just write 8.
Oh, okay. Okay. You might want to write all the ones that are visible. Okay, so when you search Bronte, please use all the ones that are visible because they're all within 15 kilometers. Because otherwise you get a different interpolation result. Once you've got all the data, then you can actually create point features or point feature class from all the XY coordinates. And for that you will need the data set for this week. So you're basically gonna link the XY, the latitude, longitude, to a location in our existing map. So what do you think? Do we need to project the data or not? Any opinions or not? What are we trying to import? What are we trying to add to our data set? We're trying to add the weather stations. What information do we have for the weather stations spatially? Latitude and longitude. So if we want to import that or add it to our map, the map should also be in latitude, longitude. So that means we shouldn't actually project it. If we project it, we find it a bit difficult to do. Okay? And you will also need to add your Excel. As always, when we do create new shapefiles, we have to go into our catalog. Because we're actually creating a new shapefile using the latitude, longitude points from our Excel sheet. Okay, so we go to our catalog, make sure we put it where we want it.
this rental information in Excel, how do we need to do that?
Well, you have to have a map, which I gave you. Because you need that mapping as a coordinate system to then,
Then file that
Enter.
export.
you need that to this. So you also need the map. No, not the map, sorry, shape file.
Shift.
The ones I gave you. So make sure you understand what we're trying to do, right? We're collecting data for which we have latitude and longitude information. And we want to create a point layer from that. Okay, so we want to tell ArcGIS at this latitude, longitude in my map, I want to have a weather station which has in the attribute table that, or I want a point which has in the attribute table that information that I have in my Excel sheet. Yeah? Okay. Let me just go. So it tells you in the specifications how we do that. We go to the Arc catalog tree, okay, where we have the column containing the coordinates. So we go right click at the table which has the coordinates, okay, and then point to create features. So from XY tables, because that's what we've got. So that's mine, it's in my sheet 1, I guess it's in your sheet 1 too. Okay, so you can just follow my instructions and you can do right click, create feature class from XY table. Okay, X longitude, Y latitude, I think that's probably it. Make sure your output is also where you find it.
Oh, why is that?
It's in the handout too.
Click spatial reference.
Right. It is also in the handout, it's actually described in the handout as well. Okay, make sure you put it into the right directory in case your map package doesn't work. We'll want to call it weather stations or something.
That's good.
Okay, oops. And we want it to be a shapefile. It's easier to share shapefiles. Okay. Coordinate system of input coordinates. Which one is it? It's WGA 1994. If you don't know, you go back to the data I gave you. So go here, have a look at, if I can do this, no I can't do this, okay, I'll just, well I know anyway, I'll show you in a minute. Don't want to go back and forth with this slow thing here. Okay, Australia, New Zealand. GDA 1994. So we're not projecting it, we're just assigning a coordinate system. Okay, and hopefully it works now. Excuse me. Okay, so it's not here yet, we have to add it. Okay, just because we've created a layer and we have to add it, so let's see. Okay, here it is, weather station. Can you see it's a point layer now?
Not accurate.
Then we add it. There we go. Okay, there's actually one station which I haven't given you because it's not in a local government area. I haven't given you the actual suburb for, but it doesn't matter. It's still, you'll still be able to use it for your interpolation. Okay, so now you can actually do the interpolation now that you've got the data. What do we do in interpolation? We're trying to fill the gaps. We're trying to have a covering value, basically, a continuous value representation for the whole area. And there's different kinds of interpolations. And they all have their ups and downs. So we have to find out and decide which one is the best. That's not always so trivial. So if you go back to the description, okay, so once we've done that, we will now go to our actual interpolation functions, or interpolators they're sometimes called as well. Okay, so we use inverse distance weighted and we will use geostatistical. And because different interpolators have different results, and also some are more suitable for some data sets than others, and it's not easy to evaluate that, what we will do is actually, we go through the process of evaluating which one is the best. And we do that by basically, you have to create, you remember, you can just copy your weather stations, your original ones, okay? Then you remove one sample point. So we just remove one entry from the table. And then we create our interpolation. And then where that point is in the original data set, we're going to check what that value is in our interpolation. Okay, so I'll just show you for one example, just so it's not too confusing, hopefully. And in the answer sheet, I actually provide you with a table. Okay, so I'll just get the answer sheet so you know. Hang on. So we have our weather stations, that's our complete set. Okay, so I'm going to first remove Rose Bay. Okay, so let's go in our data set, check the weather stations. So we can do that by attribute, opening the attribute table. And here we can see for Rose Bay, the value is 194. Okay, so that's the original value, that's the one that has been measured. So I'll put that in my table, 194 degrees Celsius, we know that. So now what I'll do is I'll actually, first I'll copy it, okay, keep your master one. So I'll just copy. Okay, and then I'll do copy, so why can't I? Oh yeah, paste, okay. So now I've got a copy of my weather stations. And I call the other one Rose Bay, which means I have Rose Bay removed. So call it whatever you want, right? Or actually I'll just call it Rose Bay sample. Okay, because that's my sample point. That's the one I'm taking out. So now I go into this table and delete this one. Okay, so I delete Rose Bay. Eventually. Okay, so I can't delete. Why can't I delete? Editor, yeah. So I have to go to editor to do this. Editor on. Rose Bay sample. Okay, now I hopefully can delete it. So I go here, and now I can delete Rose Bay sample. Okay, so I'll stop editing and it will save it. Yep. So now I have a data set which does not have Rose Bay in it. Okay, and now I'm going to run the different interpolators. Actually, what I'll do is I'll actually label my places so I can easier find them. This is so slow. Okay, and in spatial analyst tools, I should have interpolation, IDW. Okay, it's just a way to interpolate, just some mathematical method for it. I double click on that. Why can't I execute it? Why don't I have to license? Yeah, we have to go to extensions, customize extensions. It's kind of weird, I must have redone something here, so I can't remember anything. So extensions, and I'll just check them all, just to, if it does anything. Oh. This is just stupid how slow that is. It's because it runs on those virtual machines, that's the problem. Because basically the virtual machine runs on top of the Linux, and then you run something on top of the virtual machine that runs on the Linux already. So now we can do IDW. Okay, so I'm just going to make that bigger now, even though it makes it even slower. Okay, so input point feature. It's our row-space sample. Okay. Or whatever you called it. It's the one where you have it removed. Okay, row-space sample. Okay, we will use, what distance, hang on. Okay, maximum distance, we'll just do, it's in points, 1,000. I think that's what I recommended anyway. Okay, and then our output raster, I'll put in my directory, just so I've got it all together. So that is IDW without rows space. Okay, so let's see what we get. Is it still running, or is it doing nothing? Hang on, let me just get that smaller. Oh, it didn't work. Okay, hang on, that didn't work. No results. Doesn't show me. Okay, we'll just run it again and see what's going on. Okay, so my input point is still row-space sample. Oh, actually, sorry, the Z field is the highest daily value. Okay, we forgot that. So the Z field, that's the one we're using to calculate is at highest value. And the maximum distance, we make 1,000. Okay, so we didn't have the right highest value. Because the Z, often when we interpolate heights. So that's why we always think of it that way. That's why we use the Z value. Ah, there you go. Now it's worked. Very good. So I'll just put that on top. Hang on. Oh, doesn't want me to do that. Okay. Oh, this is just so fun. top. Okay, hang on. We don't want to mix things up. So I'll put it on top, make it a bit transparent so I can see where I'm going. Because what I'll do now is basically with identifier, I'm going to go over the location where Rose Bay is, that original one, and see what the value is in this one. So I can compare how good that interpolation worked for this particular value. Okay, so let me just make that a bit transparent so I can see them, and I'll just use the weather station so you can use them for the other ones too. Label, name, okay, weather stations. Okay, so Rose Bay. So now I'll just make it bigger. Hang on, I'll do the identify tool and then I'll make it bigger. So what I'll do now is I go to Rose Bay, which is somewhere. Where is it? No, but I sort of labeled the other one. Did I label the wrong one, did I? Because in this one it should be Rose Bay. Oh, tell me there's no Rose Bay now. Is it deleted it? Oh, it's removed it there too. That's annoying. Okay, hang on. Obviously copying is then not the best thing to do. Okay, so I'll just have to redo the whole thing. Okay, so be careful when you remove. You have to make sure they're different things. Still. Okay, I'll just do another one. Create feature. Latitude, longitude.
Oh, not that far back.
Hmm? Just the way it fills it in is okay. If not, you'll notice because it won't be. It will be somewhere else because it will be in the northern hemisphere or something. If you turn it around. Okay, 94, 94. Now I'll just call it all stations. Okay. Now I only removed it in my copied version, but it seems like they're linked. Okay, so I think I make the mistakes every time. Okay, so now we should have. Hang on, we have to add them. All stations. Okay, and I'll just add those names here. I'll turn off those ones. Okay, so might be a better idea to export it as a new shapefile instead of just copying it. And when you export it as a new shapefile, then use that one to delete because that's definitely a new shapefile. The copying seems to not do that. Okay, so we'll do this. Label. Okay, and here we have Rose Bay. Hang on, I have to move Rose Bay underneath, okay, because otherwise I get the information for Rose Bay. So when I now go over Rose Bay, and remember we have the interpolated surface on top, and I click here, I should get the interpolated surface number, okay. So what's the value? It's 115, call it 45, yeah? It's 42, I mean. Oh no, it's 41. So it's, okay, well, it's a 9 behind. So. Anyway, so it's 115.41. So I'll put that into my table. So it's 115.41. Okay, can you see it's actually not the same as our original one? It won't be the same ever. But what we're trying to do is use the different interpolators by taking out different sample points, but make sure that you always remove it from the whole list, so you only take one out, so you don't end up in the end with 1 point or something, okay? Then note it down, the station you have removed, and then note down the original value, that's the one we recorded from the Bureau of Meteorology. And then once you've done your interpolation, move that interpolation on top, just make it a bit transparent so you see where the stations are. Move over, click on it with identify, and it will show you the value it has interpolated. Okay, do that for, I just have, hang on, 2, 3, 4, I have only 5 stations, you don't have to do all of them, but do it for 5 stations and then see which one seems to be the closest to the original value. Is it the IDW or is it the Voronoi? Does everybody understand what we're trying to do? Yes? No? Maybe? Yep.
What's the tool that we use for the Voronoi?
Oh yeah, it's in, hang on, sorry. For some reason I didn't put it into interpolation, I don't know why, but it used to be in interpolation. So we just look where it is now. It should be in the header. There it is. In geostatistical analyst. So if you go to this, so what you actually do is like you've got the IDW now with Rose Bay removed, and now you do the Voronoi with Rose Bay removed. So you go into geostatistical analyst. It's somewhere else as well, but anyway, in interpolation, and there should be Voronoi. Hang on. Just gonna look. I thought I'd double check, but hang on. Voronoi map. Oh, it's under explore data, okay. Which is not there either. Oh, okay, I see it. Sometimes it's a bit strange. If you go to toolbars and you get this geostatistical analyst in toolbars, you will have that toolbar, and strange enough, under explore data there is a Voronoi diagram or Voronoi map. Okay, so you actually have to go to toolbars under customize. It's kind of a bit odd. It should also be in the toolbox, but it's not. So you go to toolbars, get the geostatistical analyst, explore data, and then do the Voronoi map. Okay, so you've got your Voronoi map. And we want to have Rose Bay sample. Remember that? Rose Bay sample. And what attribute do we want to use? What are we trying to interpolate? The rainfall data, yeah. So whatever you called that attribute, I called it highest daily, but it cuts it off anyway. It's this one, okay, and then you export it. So now we can give it a name. I always make it. This is actually a shapefile, but I think you can make it a raster. No, you can only make it a, yeah, it's a shapefile. It's actually vector data, okay? Voronoi is vector data. IDW is raster data. Because do you remember how Voronoi works? Basically, look for the closest other point, then bisect the distance. Anything on the side of your first point will have that value of the first point, and anything on the side of the second point will have the value of the second one. It's usually used for problems that are similar to assigning postmen to a particular delivery area. You will always send them to the closest area, or to anything that's closer to this post office and to another one. Okay, so we basically create polygons. Okay, so that is, and again I call it Rose Bay Voronoi or something. Oh no, actually I call it Voronoi without Rose Bay. That's makes more sense. Voronoi without Rose Bay. Yep, I want to add it to the map. Okay, so now I've got it here, and I know this is Rose Bay. Actually, I'll make it a bit transparent as well, just so I can see what's going on. can see Rose Bay. And basically the whole area here, which is now Dover Heights, because Rose Bay is gone, yeah? Yes, remember? Should have the same value. So if I click in here, did you see it highlighted the whole polygon? And it tells me the value, the highest daily value is 83.2. So that's interesting because it gets it from Dover Heights, right? When you look in your table, Dover Heights, hang on, what did I have Dover Heights? Oh yeah, here Dover Heights is 83.2. That's just how it works, okay? Which also shows you suitability or non-suitability of some of the algorithms for certain values. Okay, so what did I have? 83.2. Okay, so you keep doing this. And you can also, if you want to, you could use different distances. At the moment I'm using 1,000 maximum distance for IDW. You could try different distances, they might yield different results. But do that for every sample point that you take out, okay? And coming back to the issue when you copy it, that it will delete it in the original. So what you do is just use, so mine's now called all stations, just export it as a different shapefile and then delete. Okay, so I delete it as a shapefile. Okay, go here. Okay, what do I delete next? So I had Rose Bay. And now I take Randwick out. Okay, so I call that now Randwick sample. So I know this is the one that doesn't have Randwick in it. But call it whatever you want, okay? Just make sure you know what it is. So now save that, that's Randwick sample. Yep, I add that. So that now should have Rose Bay in it, but not Randwick. Yeah, not Randwick up because I'm gonna take it out, right? So now I'm gonna have to do editing again. Start editing Randwick sample. And hopefully because we actually exported the file, it should keep it in the original. So I delete, select it. So there's no Randwick in there now. Then I stop editing, save it. Now let's look at all stations. Should still have all stations in there. Yep, okay. So don't copy. Copy seems to keep the linkage between the two. So what you do in one, it will also do in the other. It's just a copy. But export it as a new shapefile and then delete the sample point. So does anybody understand why we do this? Or are you all confused? Yeah, we want to basically we want to see if we use a particular interpolator, how close the interpolated value is to the real value. And that's really, unfortunately, the only way you can check how well an interpolator works, by doing that, by taking sample points out, running the interpolators, so different interpolators on that set with a remove sample point, and then check if that sample point that you had is similar to the one that you generated with the interpolator. And then you just choose the interpolator that gets the closest. Because that's, yeah, it's the only way to check that. There's no other way of doing it. Okay, so obviously we only do 5 points, might not give you that much of a conclusion, but it gives you an idea of how you would actually have to do it when you try to interpolate your data sets, your sample points. Okay, so hopefully you will have learned now how to record your data using latitude, longitude. Okay, so, and all the data in the Bureau of Meteorology has the latitude, longitude information, and then whatever environmental data you want to record. You should be able, hopefully, to create a point layer using the latitude, longitude. Obviously, you need some kind of map to import it into. Make sure you have the same coordinate system as your data set you're trying to import it into. Okay? and then you run your interpolators. And to know which one is a good one for your full data set, we take a sample point out, run the interpolator, and then check it against the original value of the sample point we've taken out. Okay, then we create a new data set from the original one, taking another point out. So there should only always be one point missing in your sample data sets with the points removed. Okay, and hopefully that will give you a good conclusion on which interpolator works best for this data set. I mean, we don't have a lot of points really, but yeah, if you've got more points, and then maybe can run more interpolators. There's different ones, there's lots of them, there's all the kringing ones, etc. But they're all statistical, and it's very hard to know which one works best. So I haven't seen any research on which one per se works best on what kind of data. You really always end up having to test it against that specific data set you've got. So that's your best bet. And that's also, as we talked about in the lecture, there's also a reason why interpolated data sets will have errors and a fair bit of errors. Yeah, we're just trying to reduce them by making sure the interpolator is the best we can have for this data set, hopefully. Okay, and that hopefully will give you a good idea on how to do this kind of thing. Then I want you to think about how IDW works. You can see in principle, you know, I don't want to have every detail. In principle, you can actually see when we look at it here. Let's take the Voronoi out. That's our IDW. Let's just make it a bit more prominent again. You can see it's graded. Actually, it's still not very good. Okay. Just make it 0 for now. You can see it's graded, right? It sort of comes out from your sample points, and then it gradually will move the value towards the next one. Okay, so actually so let's say we're looking from Centennial Park to Marrickville Golf Course, right? So Centennial Park, let me just make it bigger, hang on. Okay, so Centennial Park has 200.7, right? So now we move towards Marrickville Golf Course. So this is obviously all the same value, right? This should all be 200.7. Oh, it's 191 already, well there you go. Oh, okay. Yeah, of course. It's different to the actual point, the actual Marrickville point. Okay, now we go to the next range. Okay, so here it's sort of, it was 191. Now we've got 185. Okay, now we've got 166. So I suspect Marrickville Golf Course will be under 166, okay, because we're actually basically moving down in our values. Okay, then we have, hang on, 141. So Marrickville Golf Course will probably have a value of less than 141, and Marrickville Golf Course itself has 139. So you can see what we're doing is actually we're having a graded change of values towards the next one. So interpolating always means we take 2 points and we're trying to work out what the values in between them might be. Using IDW, what it does is it will gradually decrease depending on how you set your distance in that. Okay, so if you change your distance, you might have smaller ranges or larger ranges, but it will always basically interpolate or guess what's in between gradually. Okay, so it's a gradual one. When you look at the Voronoi, okay, so we've got the Voronoi, hang on, after. Okay. And actually, let me do the colors different, so it's a bit easier for you to see the different ones. Okay, so now you see the Voronoi. You see the different Voronoi polygons, right? Rose Bay obviously doesn't have one because this is actually not in our data set, right? We're taking it out. But you can see that Dover Heights has 83.2. Okay, then Botanic Gardens, I think that's what it is, has, does not tell me, hang on. Should tell me somewhere what that is. Oh no, it doesn't actually. But it is Botanic Gardens. Okay, that's got 100 something. Then Renwick has 178. But you can see that in fact between 2 points there's only two values. It's either the value of 0.1 or it's the value of 0.2. Okay, so for Centennial Park the value is 200.7 and the Voronoi value is 200.7. It's the same. Yeah, the polygon will basically have the value of all the data points that are closer to its own location. And then when we look at the neighboring one, so let's say we look at Sydney Airport. Sydney Airport itself has 157, and so should that whole Voronoi diagram as well. Okay, so, or the Voronoi polygon, I mean. Yep, it's got 157, it's the same. So basically what we have here, we have like just a sharp edge. That's all we've got. So we have 2 points, and between the 2 points we assume that towards the bisection of that distance between the 2 points, it will have, so let's say we come from the right, it will have the value from that right point. Once it's on the other side of that bisection, it will have the value of the one on the left. Yeah? So we take 2 points, think of the distance between them, as a line, bisected. Anything towards point A will have the value of point A. Anything towards point B has a value of point B. When we think of rainfall data, do you think that's a good way of interpolating it? Or do you think it's a bad way of interpolating it? Why?
Doesn't give much details to any step layers.
No. And also when you think of actually any environmental data, it doesn't go, unless there is a cliff or something, right? It doesn't go from one point, edge, next point. It doesn't, or different value, it doesn't do that. It usually gradually changes a bit, okay? And there's also this Tobler's law, I think I mentioned that in one of the lectures, where we assume that anything that's closer to one certain value as one certain point will be closer in value to that as well, okay? Because it's spatially close, we assume it will have similar properties, similar values, similar whatever. Okay, so in that sense, like when you move further away, it should also change more towards the other closer points then. Not just, well, you can be a cut, but yeah, that's basically the case with environmental data. We usually think of it as a gradual change, which the IDW covers more, and Voronoi is a very sharp cut, right? But there are very good applications for Voronoi as well. If you want to really say, okay, I want everything closer to this point to have the same value, and there is applications where you want that, but maybe not for rainfall data, because that's a gradual change. So the IDW works much better here. And as I said, you might want to try, use one with 1,000, use one with 500, and one with 2,000. When you interpolate, you can easily do that when you already have your sample set. But just compare them that way and see, even which one works better in terms of the maximum distance. Okay, which maximum distance would maybe be more suitable for your data set. Okay? Good. So does everybody understand what they need to do? How to find? Oh, okay. So, okay, you've got, okay, you need the one which has all the stations. And then basically, this is on top, okay. So when you click on it now, you get the value from that interpolated. Okay? So you go on top of what's playing. And that will give you, oh, where's your watermark? That's weird. What's going on? I don't know.
롤러 롤 제발
Is this already turned on?
이거
Okay, you
못 봐니까 못 넘어 그냥
Yeah, I do not know. It doesn't make any sense. So now you've got 650.
我刚才上面
So
睡着
what you're
了
doing is like you
录了
put
一
your
半
IW on top. Okay, make it transparent so you can see the names, and then you go over the stamp you remove. Click on that location, and that will give you the value for the IW that it interpolated. And then you can compare it and say, oh, okay, it interpolated this value. How close is that to the real
哦
value?
那我直接
that
考上了就行我放后来我就直接放到我
When
邮
you
箱
open
里
the data, okay.
some giving errors
Yeah, okay, I'll just close this down.
刚好咱俩都是背的